Video, we looked at the dissolution of fluorite, CaF2, into an aqueous solution where we got calcium 2 plus ion into aqueous solution. And then for every 1 atom of calcium, we'd get 2 atoms of fluorine, also in aqueous solution. The calcium fluoride here is in the solid state, solid phase. And we calculated the concentration of calcium ion. I'll skip the 2 plus subscript just to make this a little bit easier. The concentration of calcium that we calculated was 2.1 times 10 to the minus 4 molarity, or moles per liter. So we get moles of calcium per liter of solution. Well, what we're going to try to do is convert that into parts per million. Now, when we talk about parts per million, that calculation is almost always given, or that concentration is always given as a weight fraction. So we need the amount of grams of calcium, not just the number of moles. So we're going to take 2.1 times 10 to the minus 4. That gives us the moles of calcium per liter. And then we're going to multiply that by 40.078 grams of calcium per mole. So this is the atomic weight of calcium. It's 40.078 grams per mole of calcium. That'll allow moles to cancel, leaving us grams. And if we do that calculation, then we get a value of 8.41 times 10 to the minus 3, and that is now grams of calcium per liter of solution. Let's erase the chalkboard and finish this off. So we have 8.41 times 10 to the minus 3 grams of calcium per liter of solution. But 1 liter of water, if it's pure water, is equal to 1,000 grams. So as a rough approximation, this is going to be 8.41 times 10 to the minus 3 grams of calcium per approximately 1,000 grams of solution. So you can see we've got grams over grams by taking this approximation. This is true for pure water. This is not pure water, but it's going to be pretty darn close for this case. So if we want ppm, ppm is parts per million. What we have right now is parts per thousand. So if we instead write this, well, we'll just rewrite this with an exponent on the bottom. So 8.41 times 10 to the minus 3 grams of calcium, and that is over 10 to the 3 grams of solution. We can now multiply top and bottom of this. So grams of calcium over 10 to the 3 grams of solution. We can multiply top and bottom by 10 to the 3. We multiply top and bottom by 10 to the 3 because we're not changing the concentration. The concentration is fixed by virtue of the fact that we have a solution that's in equilibrium with calcium fluoride. And we're assuming there are no other sources of calcium. So if we take this and multiply by 10 to the 3, minus 3 plus 3, those will cancel out. 10 to the 3 times 10 to the 3 is 10 to the 6. So we have 8.41 grams of calcium per 10 to the 6 grams of solution. So that's our parts per million. We've got 8.41 parts per million calcium. Now, if you're wondering how could that work out, if we take a solution, if we have a bunch of calcium atoms sitting in this solution, you can think of it this way. So why is this number 8.41 so much bigger than this number over here? We're taking a much bigger fraction of material. Well, the reason is this. If we take 1,000 grams, then we would have this case. So 1,000 grams would give us 8.41 times 10 to the minus 3 grams of calcium. But if we take 1,000 times that amount, then we'll get 1,000 times more calcium coming with us into the portion that we grab. And so that's why this number is 1,000 times bigger than this one. Anyway, that's how we convert molarity to ppm.